reference angles, or as I like to call them, quadrant cousins. And we're going to work in degrees for this. Um, First of all, let me just give you a quick example here. If we look at my first example here, I have of an angle drawn in quadrant 2, and the angle drawn is 150 degrees. The reference angle or quadrant cousin of this, now there's 4 quadrants, and every angle has a relative in all the other quadrants, but we tend to always relate them back to quadrant 1. And so let me draw that. We have a quadrant 1 relative of 150, and that quadrant 1 relative, or the reference angle of 150, is 30 degrees. And so 2 questions need to be answered. Why is 150 and 30 degrees reference angles? Why are they connected? And why does it matter? Why not just leave it 150 degrees? Why do we even bother to connect it to another quadrant? And so first, the reason of why, and well, actually the answer to both those questions are very similar. The issue is, what we like to do with these angles is we like to draw right triangles and use trigonometry to find, ratios of the sides, sine, cosine, tangent, all that type of stuff. And we can't draw a right triangle with a 150-degree angle. So we relate it or reference it to an acute angle. And this goes for all the quadrants, whether we're in quadrant 2, 3, or 4, whatever our angle is, we take it and we relate it to an acute reference angle of less than 90 degrees, which allows us to draw a triangle. So the way we get 30 degrees from 150 is we're taking 180 degrees and minusing our angle. And that's actually the rule for every angle in quadrant 2. If you have an angle in quadrant 2, you do 180 minus that angle, and you get its acute reference angle. And again, what's the point of this? Well, remember how we draw our triangles in quadrant 2. So we draw that vertical line down to the x-axis, which makes a right triangle, and then we use angle theta over at the origin. Now, what's that angle? That is 30 degrees. Angle theta is 30 degrees. And the way to understand that is, we see that this angle here is 150 degrees. Well, the x-axis is 180 degrees, so 150 degrees is 30 degrees short of the 180 line. And so when you draw a triangle in that second quadrant, 150 degrees is 30 degrees away from that. So that's why in quadrant 2, the reference angle is 180 minus your angle, because it's basically saying, how short of 180 degrees are you? So that's why we do it. So we can draw a triangle here, and now we can, do opposite, adjacent, hypotenuse, and we could do all of our trig functions on all that stuff now that we've turned 150 degrees into a 30-degree reference, which allows us to, draw our triangle and go from there. The key to take away is that in quadrant 2, you do 180 minus theta, because it's all about how short of 180 are you. And so actually down here on the bottom right, I'm going to list all of these because I want to have them all in one spot. So 180 minus theta in quadrant 2 is the rule. Moving over to the top right, I have an angle drawn here of 210 degrees. And again, its reference is going to be, it's related to the other quadrants, but most importantly, it's related to quadrant 1. And this one, again, is going to be a 30-degree reference. And again, it has to do with how we draw our triangle. We draw our triangle to the x-axis and have our angle in here. And since we know this is the 180 line, 210 is 30 degrees more than 180. And so it's very similar to quadrant 2. It has to do with that 180 line. It has to do with how we draw that triangle. Instead of being, oh, we're 30 degrees short of 180 in quadrant 2. Well, in quadrant 3 here, we're 30 degrees more than 180. And so when we draw that triangle, the angle we're going to use is a 30-degree angle off the x-axis, off that 180 line. And so the rule for quadrant 3 is very similar to 180 minus theta. In fact, it's your angle theta minus 180. And so the rule is very, very similar. And the reason why they're so similar is because they both have to do with this 180 line on the x-axis. Both of the triangles go to that line. You know, either how short of 180 are we, or how much longer than 180 are we, you know, off that x-axis. And lastly, in quadrant 4, I mean, we're not going to discuss quadrant 1 because quadrant 1 is already acute, so you don't need to reference it to acute. It's already there. But in quadrant 4, it's not going to be a reference to the 180 line over here. It's going to be a reference to the 360 line over here, because how we draw our triangles here. We draw it to the 360 line, and our angle is measured in here, and this is another 30-degree reference angle. So 330 degrees in quadrant 4 is a 30-degree reference angle for quadrant 1, and the rule here is how short of 360 are you? You know, because we're drawing that line up to the x-axis. 360 minus theta. So those are your rules. That if you have an angle in quadrant 2, you do 180 minus it to find its reference. If you have an angle in quadrant 3, do the angle minus 180 to find its reference. If you have an angle in quadrant 4, you do 360 minus it to find its acute reference, which is when you draw your triangle, you know what that angle is going to be over at the origin. So real quick, let me do an example of all of them. Let me just minimize that. All right, let's say, you know, let's list all the quadrant cousins of a specific angle. Let's go with a 60-degree angle here. Now, a 60-degree angle in quadrant 2 would be 120 because it's 60 short of 180. And in quadrant 3, it's 60 more than 180. So 60 more than 180 would be 240. And in quadrant 4, you know, 60 short of 360 would be 300. You know, so 60, 120, 240, 300, they're quadrant cousins of each other. They're all relatives of each other, but they're all going to become references of 60 degrees, because 120 is 60 degrees off the x-axis, and 240 is 60 degrees off the x-axis this way, and 300 is 60 degrees off the x-axis that way. So they're all really references of 60 degrees.